All right, today we are pulling back the curtain on a hidden war, a high-stakes battle that's being fought online, every single second. It's a fight between AI that's designed to trick you and the AI being built to stop it. And this isn't some far-off sci-fi plot, it's the new reality of our digital world. So let's get into it and see how this invisible war is actually being fought. And if you think this is just theory, check this out. This really happened. In 2024, cybercriminals used AI to perfectly clone a CEO's voice. They then used that fake voice to call an employee and try to get millions of dollars transferred. Just think about that. Millions of dollars hanging on whether or not you can trust what you hear over the phone. An event like this shows us, without a doubt, the game has completely changed. And that really gets to the heart of it, right? AI has opened up entirely new battlegrounds in our digital lives. It's not just about spotting a suspicious email with bad grammar anymore. Nope. Now, the attacks are targeting our most basic, fundamental senses, our hearing and our very sense of trust. The things we rely on to know what's real are now being turned into weapons against us. So let's start with that first battleground, the human voice. We're going to dive into the threat of synthetic audio. You've probably heard it called audio deepfakes. And, more importantly, how we can even begin to fight back. Okay, so first things first, what exactly are we talking about here? Well, an audio deepfake is basically any time AI is used to create or change a piece of audio to make it sound just like a real person, or even to create totally new, fake sounds from scratch. The whole point is to make it so convincing that your ears literally can't tell the difference. Now, this is where it gets really interesting, because this shows the two main ways the forgers actually create these fakes. On one side, you've got speech synthesis, or TTS. Just think of it like creating a voice out of thin air. You give the AI some text, and it speaks. The big challenge is making it sound natural, not like a robot. Then, on the other side, there's voice conversion, or VC. This is more like a high-tech impersonation. The AI takes one person's voice and morphs it to sound like somebody else, all while keeping the original words intact. So, with these crazy good fakes out there, how in the world do we fight back? Well, this brings us to the heroes of our story, the AI digital detectives. These are the systems that are being trained to spot the tiniest, most subtle clues that a voice isn't real. Now, the actual process is incredibly complex under the hood, but you can really boil it down to these 4 key steps. First, the system gets the audio file. Next, and this is the magic right here, it does something called feature extraction. This is where it's listening for all those telltale signs of a forgery. After that, an AI classifier takes a look at those features, and finally it spits out its verdict, real or fake. So let's zoom in on that feature extraction step, because this is where the detective work happens. And there are 2 main ways the AI learns to listen. On the one hand, you have handcrafted features. This is where human experts literally write the rules. They're like seasoned art detectives who know exactly what kind of digital brushstroke to look for. Then you have learning-based features. This is totally different. Here, an AI model just listens to millions of examples of real and fake audio, and it teaches itself what to look for. It's way more powerful, but the downside is that sometimes its methods can be a total black box. Okay, let's switch gears and move to the second front in this digital war. See, deception isn't just something you hear. It's also hidden in the text we see every single day, especially in the web links we're all clicking on. Malicious URLs are one of the oldest tricks in the book, but you guessed it, AI is changing this battlefield too. So why are these links so darn hard to police? Well, unlike a normal sentence which has grammar and structure, URLs are just a chaotic mess. They don't have a lot of inherent meaning, and they're usually stuffed with a bunch of digital noise, like tracking codes and random characters for session IDs. It's a jumble. Which leads to the big question, right? How on earth can you teach an AI to read that chaos? How does it learn to spot the hidden grammar in a link that's designed to trick you? Well, the answer is you build a specialist. Meet URLbert. Now, I know this diagram looks a little intimidating, but don't worry about the details. Here's the key takeaway. It's an AI model that has been trained from scratch on billions and billions of URLs. Its one and only job is to learn their unique hidden language. So how does it pull this off? Well, URLbert's very first mission is to learn the unspoken rules of that chaos. It needs to figure out what the proper structure and sequence of a legitimate web address actually looks like. And here's the really clever part. During its training, the AI basically plays 2 games, over and over.
billions of times. In one game, replaced token detection, parts of a URL are swapped out, and the AI has to spot the fake piece. In the other game, shuffled token detection, the parts are all scrambled up, and it has to recognize that the order is wrong. By doing this constantly, it builds an incredible intuition for what a normal URL is supposed to look like.
So, does all that special training actually work? Oh yeah, big time. Just look at this chart. You've got your standard, general-purpose AI models, and they do a pretty good job at detecting phishing. But URLBERT, the specialist that was built for this one single task, it comes out on top, with over 97% accuracy. That's proof that this kind of focused training makes a huge tangible difference. So you see, whether we're talking about a fake voice or a malicious link, the underlying story is exactly the same. We're watching a constant escalating battle. The second a new detection method is developed, the attackers are already hard at work trying to figure out a new way to beat it. This is a true technological arms race, an ongoing battle of wits. And this battle is nowhere near over. In fact, researchers are tackling some absolutely massive challenges right now. For example, how do you build a detector that can spot a totally new kind of attack it's never seen before? How do we make these models small and efficient enough to actually run on our phones? And critically, how do we get these AI detectives to explain why they think something is a fake? And can you do all of that while still protecting our privacy? And all of this leads us to the final, really important question. The technology to create these fakes is getting better, cheaper, and easier to use every single day. So as the forgers get smarter and faster, the ultimate challenge is this: can our digital detectives evolve quickly enough to keep up? The security of our entire digital world really depends on the answer.